Hi, so today we'll be looking at Reaper latency correction, and in this video we'll be looking at both audio latency correction and as well as the MIDI latency correction in Reaper DAW. Okay, so here I have this project, and this project is especially made for our this topic. Okay, Reaper latency correction, and here I have two sections: audio latency correction and MIDI latency correction. And in audio latency correction we will be looking at two methods. Okay, method 1 and method 2. Okay, and after that we'll be moving to MIDI latency correction. Okay, so first let us look at audio latency correction. Okay, so here are some of the setups which you have to do to conduct your loopback test. Okay, so simply you have to do your loopback test with respect to your audio interface. Okay, because you are measuring the audio latency, okay, of your audio interface in connection with your PC. Okay, so simply connect your audio interface with your PC. Okay, yeah, and your audio interface will be powered on automatically. Yeah, now you will also need this studio monitor cable. Okay, you probably have this studio monitor cable if you are using this audio interface and your studio monitor. Okay, so simply you plug this one in to any of these output port. Okay, I'm using the left. Now this same wire. Okay, you can use any of the input. Okay, here I'm using input 2. Okay, now for method 1 of audio latency test, which we will be doing, you have to put this gain, this input gain, to all the way to the down. Okay, and here in the line and instrument you have to put in line. Okay, line, and direct monitor of this audio interface off. Yeah, and this monitor knob all the way to the up. Okay, and no use of phantom power. Okay, because the XLR jack will only use the phantom power. Okay, the TS jack will not be using the phantom power. So for method 1 of audio latency test, this input gain will be all the way to the down, and for method 2 of our audio latency test, will be increasing the input with respect to our source sound. Okay, which I'll be showing later. Okay, just to know this much for now. So yes, this is the setting, okay, which you have to do, and you are ready to conduct your loopback test. Okay, and to conduct your loopback test, you turn off your studio monitor power. Okay, we are simply seeing the values. Okay, and seeing the waveform. Okay, and we will be correcting. We don't need to listen sound from our studio monitor. Turning off your studio monitor is critical. Okay, or you might harm your studio monitor and your ear. So yes, this is the basic settings, and you are now ready to conduct your loopback test. Before we proceed for audio latency correction, first we have to look some preference. Okay, here option, preference, or control P. Okay, simply, and here you go to audio device. Okay, and you choose your audio system to ASIO, and here ASIO driver, choose your audio interface driver. Okay, and now the important thing here is this ASIO configuration. Okay, my audio interface and driver has reported this value. Okay, my audio interface is using a sample rate of 48,000 Hz and buffer size of 192. Okay, it is automatically determined by my audio interface. Okay, and here this you see sample rate, here this and this sample rate means same thing. Okay, and this block size and this buffer size means same thing. Okay, here I have not requested. Okay, I have directly set in my ASIO driver setting. Okay, so this is important thing. Okay, because anytime you change this value, you might need to do the latency correction test again. Okay, so this is important. And let us come here in recording. Now here you'll see use audio driver reported latency. You should keep this checked on. Okay, and here you'll see input manual offset. Okay, and you can put the offset value either in milliseconds or samples. Okay, we'll be using samples. Okay, currently it is in neutral position. Okay, so for now you can close this window. Okay, but later we'll be coming to this section again. Okay. Okay, now let us look at method 1. Okay, now let us look at recording audio latency offset test. Okay, so first we'll be looking at method 1. So this is method 1. Okay, so simply you first disable the master send. Okay, and you insert one plugin here, reinsert. Okay, and this is the GUI of this plugin. Okay, so this hardware sends means which output port you are using in your audio interface. Okay, we are using left output. Okay, so left means output 1 and right means output 2. Okay, so we are choosing output 1. In right we are not using the right output of our audio interface. Okay, for this test. Okay, so none. MIDI we are not using anything MIDI. Okay, so none. Hardware returns, this simply means which input port you are using in your audio interface to conduct this test. We are using input 2. Okay, you can choose input 2 in either this place. Okay, I'm simply aligning input 1 for left and input 2 for right. Okay, for easy workflow, so I'll be choosing here input 2 and here none. We don't want any other input to concern in this test. Okay, we want only input 2 to concern in this test. Now you are ready to test. Okay, but before testing just make sure. Okay, double check this. Okay, these options value all are 0. Okay, all are in neutral position. Okay, and this is checked. Okay, all the time, so we are good to go. Okay, so test. Okay, hit ping detect. We got additional delay compensation 10 samples. Okay, test again. So yes, it is 10. Okay, so additional delay compensation is 10 samples. Okay, this means in addition to this latency, okay, the driver reported latency, we have to apply this additional delay compensation. Okay, just to make sure that you are receiving input in your input to just record on this. Okay, disable the monitoring. Okay, disable this record monitoring or turn off your studio monitors and studio headphones. Okay, and choose your input and hit ping detect. We are receiving input. Okay, and still the value is 10 samples. Yeah, so this is verified. Yeah, so it is 10 samples. Okay, so now simply copy this value and paste here, Control P. Now here, yeah, input manual offset 10 samples. Okay, in addition to the driver reported latency. Okay, this we have to input manual offset by 10 samples. Okay, now again you do test and the value here should come 0. It's 0. Okay, so your latency is compensated. Okay, so this is method 1 and the value we obtain is 10 samples. Okay, now we will be conducting method 2 and that method 2 should also yield the same 10 samples value. Okay, okay, now let us look at method 2. Before conducting our this method to test, just make sure you are in the neutral position. Okay, just go to the preference audio and recording, and here recently we corrected with 10 samples. Okay, but we are conducting this test again. Okay, so let us put here 0. Every value should be 0. Okay, every option value should be 0. Okay, we should be in the neutral position to conduct our test in a fresh manner. Okay, and make sure this is checked all the time. Okay, hit apply. Okay, so for method 2 you change your timeline ruler to samples. Here, yeah, samples, and your transport bar also you change to samples. Okay, or simply you can share this. Okay, use ruler time unit. Okay, now in track 2 we have here method 2 track 1 and method 2 track 2. Okay, and this method 2 track 1 is simply our source sound. Okay, and this method 2 track 2 is our loop recording track. Okay, and simply we'll be comparing these two tracks to find the latency. Okay, So let us first select one region, okay, one zero crossing point region, okay, in this method to track one source sound, okay. So let us select this item here, yeah, and hit Z. So we reached in this zero crossing point, okay. Now hit M to create marking point. So now we will loop record this sound, okay, and will be coming in this region, okay, this same region, and we'll be comparing the latency, okay. So simply you record arm here, turn off this recording monitor, okay, or turn off your studio monitors and your headphones, okay, and choose here your input 2, okay, because we are using input 2 for this test, okay. And make sure you put this cursor all the way in the beginning, okay. Now before conducting the test, you have to have the proper recording level, okay. For that you have to know the audio level of your source sound, okay. For that just go here and just play. It is minus 8.5 dB, okay. Your source sound is having minus 8.5 dB, and now you have to bring your recording level nearby minus 8.5 dB, okay. So now simply increase your input to gain, okay. Currently it is all the way to the down, okay, because in method 1 we have to set this input to gain to all the way to the down, okay. But in method 2 now we have to slowly increase so that this recording level is at minus 8.5 dB, okay, for this test, okay, for this particular case. So simply hit play and you set your recording level, okay, by slowly increasing your gain. Okay, it is minus 8.2, okay, nearby. So your recording level is set, yeah. Now you can simply record. This much is enough for us, okay. And now let us go nearby this region, yeah, and now select this item, yeah, this item, and now hit Z. We reached here, okay. So hit M to create a marker. So here this item was having zero cross point at this marker, okay, and this our loop recorded item has the zero crossing point in this marker 2, okay. So now let us see how many samples are there up to marker 1. 516, okay. And now let us see how many samples are there up to marker 2. 526, yeah. So 526 minus 516, 10 samples, yeah. So we got the latency of 10 samples, okay. And method 1 also gave us the same result, okay, 10 samples, yeah. And now simply put your this value here, 10, hit apply, okay, delete this loop recorded item, okay. And now let us verify again, okay. So we will loop record again. Make sure this cursor is all the way at the beginning and simply record again. Now this was our source sound, yeah. This was our source sound, yeah. And coming in this region, if we hit Z, this was the zero crossing point, okay. Very dead center, okay, in marker 1. Now let us come in this item, our recently loop recorded item, okay, and hit Z. Before this cursor was here, now it is here, okay, and it is dead center at marker 1, okay. So it is aligned, okay, and now we are not having any latency, okay. You can see every points are very aligned, okay. Yeah. So in this way the latency is corrected. And here I have two tracks. Okay, this track will be having my BST instrument. Okay, and here I have simple MIDI data. Okay, here I have one bar of information. Okay, bar 1, yeah, bar 1, and we are having 4 bits. Okay, in bar 1. Okay, and I have already quantized this MIDI notes. Okay, the attack position of every notes starts exactly at every bits. Okay, this note starts exactly at the position of bit 1. This note starts exactly at the position of bit 2. This note starts exactly at the position of bit 3, and this note starts exactly at the position of bit 4. Okay, very quantized. Okay, the note starts exactly at the bit starting point. Okay, and the sound is also expected to start in that way. Okay, but we will be having some issue. Okay, and we'll be looking about that. So in this, simply I use this drum machine. Okay, and a simple kick sound. Okay, every bit is receiving the kick sound. Yeah, kick. So here in this track, simply I have my VST instrument, and here I have the MIDI data in this track. Yeah, and in this track simply I'll be having the audio freeze data of this track. Okay, and the routing of this VST instrument would be disabled from master and directly send it to VST freeze. Okay, here like this. Okay, we don't send this MIDI information, we are sending the audio. Okay, because we want to freeze the audio. So simply if you play, you will be hearing like this. Yeah, you remove this marker. Okay, this was from our previous test. So let us freeze the audio. Let us look here. Okay, so this is the start position of our MIDI note. Okay, let us create marker. So this is the MIDI start note. Okay, this marker. Now select this item and you hit a tab. Okay, to come to the attack position of the sound. Okay, of this bit. It first select this item and hit tab here. Yeah, here the cursor is here. Now put another marker here. Okay, marker 2. So your MIDI note starts here, but your sound starts from here. Okay, it simply means this. Okay, double click here. Now here sample is 24,000. Yeah, and here 24,012. Okay, now what we want is, we want this sound, this attack position of this sound to come exactly here in this position. Okay, in the attack position of this MIDI note. Okay, this MIDI note when pressed and the sound of your VST should come at the same time. Okay, we are having here some latency. Okay, this is very less. Okay, it might not be noticeable, but if you are having more latency, it will be noticeable. Okay, so for this you have to do some manual work. So first let us delete this. Okay, and you go to the routing and again route. Okay, no MIDI, and now here playback offset. Okay, so we are having the offset of 12 samples. Okay, 12 samples here. Yeah, because we were having the sound attack in this region. Okay, but we want from this region. Okay, so we have to go back. Okay, so now again let us freeze the track. Now see, the MIDI note of this item and the audio attack of this item are aligned. Okay, So this is the marker 1 of our before example. Okay, this was the marker 2. Okay, before this attack of this item, this was here, now it is here. Yeah, so it is corrected. Yeah, it is corrected due to this setting. Okay, in samples. Yeah, now let us verify here. Let us go here, select this item and hit tab. Now this must be at marker 1. Yeah, it's at marker 1. Okay, here you can see the marker 2 is not placed at the exact point. Okay, it is placed somewhere in the between of these 2 points. Okay, so here the cursor is coming at between. Okay, 2 points. Yeah, so it simply means this cursor is at this marker 1. Okay, and the latency is corrected. Okay, okay, now let us use another our VST instrument and verify this again. Okay, now let us look at the second example of this MIDI latency correction. Okay, so before I was using the drum machine. Okay, now I'll be using synth. So now for this track, VST track, I'll be using now this synth and init patch. Okay, so simply I have here marker 1. Okay, set at the attack position of bit 2. Okay, bit 2 MIDI note. Okay, here, and simply I'll be routing to this VST freeze track. Yeah, and MIDI note none, only I'll be routing audio. Yeah, so simply freeze. This is the audio, okay, which we obtained by freezing this track. Yeah, so first you select this item. Okay, hit tab. So this is the attack position of this bit. Okay, for this audio. Okay, hit M to create marker. Hit M. It has not created yet. Okay, now it has created. So this is the attack position of this MIDI note. Yeah, but the attack position of this sound. Okay, from where it will start to produce sound is this. Okay, we are having gap of this much. Okay, and how much gap is this? We can read here like this. Okay, 24,000 samples up to marker 1. Okay, and here 24,082 samples. Okay, so the difference is by 82 samples. Okay, so here you have to set that correction. Okay, now this is the freezed audio of this MIDI information. Okay, and the VST applied to this track. Okay, so this is little bit forward. Okay, so we have to take it backward. Okay, so to match here. Okay, we have set this, delete this. We have to test now again, and you have to route again. Yeah, this is important. Okay, and samples. Now again freeze. Okay, now again you come to the beginning of this item, hit tab. Now this cursor should be going to marker 1. Okay, yeah, it is in marker 1, not in marker 2. Before it was in marker 2. Yeah, so the latency is corrected. Yeah, you can see the attack of this sound. Yeah, is now aligned with the MIDI note. Yeah, so the important shortcut keys involved in this video are shortcut keys related with zero crossing point and our transient or attack position. Okay, so first let us see about the zero crossing point shortcut keys. Okay, so for zero crossing point, you first select your item. Okay, which item you want to proceed with. Okay, so I have selected this. Okay, you see I have clicked and I selected this. Okay, so this is my waveform. Now simply I will be pressing or hitting Z key. Okay, in my keyboard. I reached at zero crossing point. Yeah. Again I hit Z. Again, yeah. If you hit Z, the cursor will move forward. Now if you hit Shift and Z, the cursor will move backwards. Okay. Zero crossing point. Yeah. The cursor will be going exactly at zero crossing point. Okay. Each step. Yeah. Step by step, it will be going. Okay. It will not skip this and it will be going to here. Okay. It will first go here and then again if you press Shift and Z, it will be coming here. Okay. So this was the shortcut keys related with zero crossing point. Now let us look at the shortcut keys which helps us to reach exactly at the transient position or the attack position of the sound. Okay, so here I have 4 bits. Okay, and let us go in the first bit. Now select this item, yeah, and hit tab. The cursor is in the second bit, transient or attack position. Okay, again hit tab. Yeah, this is the attack position of this bit. Okay, again hit tab. Again here. Yeah, let us see again. I hit tab. It is here now. Yeah, so from here this sound is producing. Okay, this is the attack of this sound. Okay, again hit tab. Again you reach here. Simply hitting tab will move your cursor forward. Yeah, and if you hit Shift and tab, the cursor will move backwards. Okay, backwards exactly at the attacker transient position. Okay, I hit tab, the cursor moves forward. Yeah, I hit Shift and tab, the cursor moves backward. Yeah, so the important shortcut keys involved in this video are for zero crossing point and attacker transient position. Okay, so these are the important shortcut keys involved in this video. Okay, so in this way we saw MIDI latency depends on the VST instrument applied to it. Okay, because in first example we obtained the correction factor of -12 samples, and in our second example we obtained the correction factor of -82 samples. Okay, but the correction factor of both the method, okay, method 1 and method 2 for audio latency was same. Okay, in MIDI we obtained a different correction factor. Okay, so in MIDI you have to do correction track wise. Okay, like that. So yes, this is all what I know about Reaper latency correction of audio and MIDI. Okay, if you think you have some better workflow, then you can share. Yes, if you have something to correct, then you can correct. So yes, bye for now.